Today we're going to finish our exploration of factoring by factoring problems completely with whatever steps are needed, and then also factoring problems completely using whatever steps, and then following up to solving the problems. So starting with number 1 and number 2, all we're going to be doing is factoring because there's no equation. It's a polynomial. There's no equal sign. So I want you to do these two on your own. Just as a reminder, you're going to first look for the greatest common factor, factor it out, and then look at the remainder and see if it can still be factored again, and just get it all the way down to the fully factored form. So pause your video and then check back for the solution and explanation. So in number 1, I first removed the greatest common factor of 4c. And once I removed that 4c, I could see, after I rewrote the problem, I could rewrite it 4c times c squared minus 1. And looking at the c squared minus 1, I realized it was c squared minus 1 squared, or the difference of two perfect squares. So I went ahead and split them apart, finished factoring the binomial, and that gave me the answer. Number 2, I tried at first to remove the greatest common factor and realized the 3 can't be divided by the 2. So I went ahead and just put it through the area model, giving me that answer. Okay, number 3 and number 4, same process. I want you to pause the video and do those two, and then check back with the answers. On number 3, I was able to take out a greatest common factor and still factor my remaining trinomial. And then on number 4, I took out my greatest common factor and I started trying to factor the trinomial, but there was nothing that worked. None of my factors for -8 would add up to a positive 3. So I couldn't factor any further, leaving my answer at 2 times x squared plus 3x minus 8. Okay, now turn the page. So now on this side of the page, we're going to factor the problems completely and then go the next step, setting each equation equal to 0 and solving the quadratic. So I want you to do number 5 and number 6 on your own. Go ahead and pause your video while you do it and then check back for the solution and explanation. So on number 5, I was able to remove the greatest common factor of 3, and that I had a remaining trinomial that was also able to be factored. And then I took my two factors with variables equal to 0. And this time I decided to write my answer as a data set. It can be done either way. So x equals 2 and x equals 5 is the answer. Then on number 6, when I factored out my greatest common factor, I was left with a difference of two perfect squares inside my parentheses. So c squared and 6 squared. So I went ahead and I split them apart to get my fully factored form. Then I set each factor equal to 0 and wrote my answer as a data set, c equals -6 and 6. Okay, on number 7, 8, and 9, notice on 7 and 8, they're not equal to 0. So before you can do anything, the very first thing you've got to do, you've got to get it equal to 0. So you'll have to 0 out the -125 and 0 out the 4 to 8. Then take it through the process of factoring it and solving it. Pause your video and then check back for 7, 8, and 9. On number 7, you needed to remove the greatest common factor and factor the remaining trinomial, and then set them equal to 0 and solve. On number 8, after I got rid of it equal to 0, I saw I had a difference of perfect squares, and so then I set my factors equal to 0, and that gave me n equals -4 and 4. Number 9 was already in fully factored form, so all I did was set it equal to 0. On number 10, there's a lot of different ways that you can go approach it. So what I want you to do is to decide how you're going to go. Where's an easy place to begin? Figure out the puzzle. So pause your video while you're doing it, and then check back for the final explanation. Okay, and I used the plug and check method because they'd already given me the answers. And so I just tried them and kind of used some logic on which ones to use, and 12 ended up being the answer on this. When I plugged in 6, it was too low, and 39 was way too high, so that's how I got down to 12 as being the answer.